Next, our contestant will be presenting on megamite nanoparticles, field polyvinyl alcohol as potential bone tissue engineering scaffold. From Faculty of Mechanical Engineering, please welcome Nur Hasrul Akmal bin Ngadiman.
Have you heard about a large bone defect problem? No? Okay, let me explain by telling you my story. I have an uncle who suffered from a bone cancer. As a treatment, doctor removed a part of his bone which was infected with a cancer cell. Thus, there was a gap in between his bone, right? That's what we call as a large bone defect. Then what did they do? They did an autograft transplant by taking a part of bone from his body and replace it at the defected area. Unfortunately, that bone also was infected with a cancer cell. So it means he need to undergo second surgery. What? Second surgery? It was very painful for him. For the second surgery, they took a bone from a donor. It's called an allograft transplant. And again, he was not lucky. That bone also infected with a disease, and that disease was transmitted to him. He's a very strong man. He fought to his last breath. This incident inspired me to do a research. By using a tissue engineering knowledge which combining material, mechanical, chemical, and biomedical engineering principles, I'm doing a research on development of bone scaffold. What is a bone scaffold? Bone scaffold is like a bridge for cell to attach, grow, and generate a new bone. Bone scaffold will fit on the gap at the defected area, and the new bone will grow on it. As the new bone grows, bone scaffold will degrade with the time. So, it means we just need only one time of surgery. On my scaffold, I'm adding a hermite nanoparticle which I developed it by myself. Because it's very expensive in the market, so I can cut the cost of production up to 80%. My hermite nanoparticle also have a super paramagnetic properties which can enhance the cell attachment and cell growth rate. For the process, I'm combining 3D printing process and electrospinning process. The best thing about 3D printing process is we can develop any kind of shape in any size that we want easily. And it also provides a good mechanical strength, which is very important for the bone scaffold in order the bone scaffold withstand with a loading bearing of bone. Meanwhile, electrospinning process produce a nanofiber which mimic the extracircular matrix of natural bone tissue structure. So, cell will live in my scaffold like in their natural environment, although we just mimic it, but don't worry, that cell will never know that. Therefore, it can enhance the new bone formation. As a conclusion, my scaffold will not only possess a good mechanical properties, but also having a good biocompatibility properties, and it is the best choice to replace the current treatment to treat a large bone defect problem. Uncle Joe, although at that time I cannot help you, but I hope one day if my scaffold can be used clinically, it can help 1,000 of people which has a similar problem like you, and for sure, it will turn their tears into a smile. Hasrul Akmal bin Ngadiman. Assalamualaikum warahmatullahi wabarakatuh. Thank you.